Hello, everyone. I know sections 11.9, 11.10 are hard, so even though the homework's already been due, I figured I'd do a problem video for these sections, just so we could get a little bit more comfortable with them. So let's look at some 11.9 problems first. 11.9, we're coming from the viewpoint that the only function we know the power series for at this point is 1 over 1 minus x, and that has a power series x to the power n. Okay, so anytime they give us in section 11.9, anytime they give us another function, we want to compare it to this, to 1 over 1 minus x, and we want to kind of modify our function to match 1 over 1 minus x. And then we're gonna modify the power series in a similar way to get a power series for our function. Okay, so let's see what I mean. Okay, so whenever in 11.9, there's a couple techniques, but whenever they give us a function, let's see, we can divide our techniques into kind of two phases. First, just kind of playing around with our power series, and then, or our function, and then the other phase of techniques is integrating and differentiating. So let's start off with simple stuff. If they give us a fraction, and let's look at this example, okay, 1 over 1 plus x, and it's very similar to 1 over 1 minus x. What I'm going to do is I'm first going to try and rewrite this. I'm first going to try and rewrite my function in the form 1 over 1 minus something in parentheses. And then maybe there's something out here as well. Okay, so let's look at this example. How can I rewrite this 1 over 1 plus x? How can I rewrite that in the form 1 over 1 minus something? Well, if I want the sign that this operation in the middle to be subtraction, all I got to do is do 1 over 1 minus negative x, right? And then there's nothing outside, okay, or I could just think of it as the number 1 outside these parentheses. So how do I get my power series now? My power series is going to be parentheses to the power n, and what goes in parentheses is just whatever's in parentheses here. Okay, so my power series for 1 over 1 plus x is just going to be negative x to the n. And then once I get this, now the rest would, you know, this is the power series, but I could maybe simplify it by splitting up the terms. So negative x to the power n is the same thing as negative 1 to the n, x to the n. Okay. They're the same thing, but usually if we have a power series where we have something in parentheses, we want to split it up as much as possible. Okay. So now let's just see several examples of this kind of technique where they give us a function and we just modify it to kind of match 1 over 1 minus x. So this is number 5 from the textbook. How about 2 over 3 minus x? Okay, I kind of do my numerator first and then move to the denominator. So first thing is I want this to be a 1 on top, right, in the numerator. So I'm going to pull that 2 out. Okay, and I get this. And then let's see, I have a minus sign here, that's good, but I have a 3 here, and I need that to be a 1, right? So I'm going to pull that 3 out. Okay. And then what does that do to the rest of my stuff in parentheses? Okay, that becomes a 1, but then this becomes x over 3, right? And I could think of that x over 3 as being in parentheses. So now I have a constant, and then I have 1 over 1 minus something in parentheses, all right? So I know I have a power series for this part. It's just going to be x over 3 in parentheses to the power n. And then I have a 2 over 3 out front. Okay, and now this is my power series, and then the rest is all just simplifying. Okay, so let's again split up the stuff inside our power series as much as possible. Okay, and then if I have stuff outside my power series, I want to try and bring it into my power series. Okay, if let's see, I bring in the, oh, this is wrong. Let's do this just step by step. I have 2 over 3, 3 to the n. Okay. Now I'm multiplying, and this is my little number dyslexia. I write 2's instead of n's a lot. Okay, now we're good. Now I'm multiplying this x to the n over 3 to the n by 2/3. Okay, so how could I combine these 3's? 3 to the n times 3. That could become 3n plus 1, and then I have a 2 out front. So maybe my final answer could be written like this. 2 times x to the n over 3 to the n plus 1. All right. How about number 6 from the book? I have 4 over 2x plus 3. So let's try and find the power series for this and the interval of convergence. So up until now, we've just been doing power series. So let's also try and find interval of convergence. All right, so I want to get it to match 1 over 1 minus something in parentheses, maybe something outside. So let's see, I need a 1 in the numerator, so I'm going to pull the 4 out. And then I need to change, let's see, just to get it in a format that's more familiar. Same thing, right? I've just kind of reordered the 2x plus 3. Okay, now I want this to be a 1, and I want that to be a negative sign, and then this is going to be my stuff in parentheses. Okay, so let's do this kind of moving left to right. First thing I would do is bring out that 3. All right, and now let's change this to a minus sign. And we'll get this, right? All right, so now this is in a form I can make a power series for. The power series for this thing would just be negative 2x to the power n. And then I have this 4/3 up front. Okay, now this is a good power series. Let's just simplify it by splitting everything up. So I could split it up like this, and then I could split it up even further to negative 1 to the n, 2 to the n, x to the n, 4 over 3. And then let's bring that 4/3 inside. Okay, and then notice that 4 is 2 squared, right? Okay, and then let's see, I got 2 to the n times 2 squared. So I could rewrite this. You know, I'm showing a lot of steps here. You know, maybe on your own, you can just do this in a couple steps. I'm just trying to show everything so nobody gets lost. And you know what? I'll write it like this. Okay, and this will be my power series. Now, okay, this is my power series. Now let's find the interval of convergence. So how do I find the interval of convergence? I can just do ratio test. This is section 11.8 material. Okay, so I do ratio test. Let's see, so I can ignore any negative signs because I'm doing absolute value. Let's see, so I would have okay, simplifying this, let's see, the 1/3 would cancel, and I'd have 2n plus 3 over 2n plus 2, x to the n plus 1 over x to the n, simplifies as 2 times x, and I want this to be less than 1, right? So I need 2x to be less than 1, greater than -1, x is less than 1/2, greater than -1/2. Okay, so my interval is going to be something like -1/2 to 1/2. Next step, plug in these values to see if my series converges. And what series am I plugging them into? This thing. So let's see, if I plug in -1/2 for x, I would get 4/3. Let's see if I simplify my series. I get 4/3. Okay, so it's going to be divergent at -1/2. It's also going to be divergent at +1/2. Okay, so I don't want to include, I'm kind of skipping some steps here. Hopefully you guys can do this on, if you don't see it right away, you can plug these in and figure it out on your own, but it should be divergent for both. You can check me on that. So my interval of convergence, I wouldn't want to include those endpoints. So my interval of convergence would just be this. And if they ask me for radius of convergence, well, that's just half the length of this interval, right? So radius of convergence would be 1/2 as well. Okay. Let's do one more example of these, this first simple technique. So let's do an example, x² over x to the 4th plus 16. Okay, so now it's more complicated because we have an x² in the top, but the premise is the same. I want to convert this into something like 1/1 minus parentheses, maybe with something out front. Okay, so let's see, I got an x² on the top. So my first step, just like if it was a constant, I would bring that x² out front. Okay, and then I got x to the 4th plus 16. Well, my order's a little messed up, right? I usually want 1 here, so I'm just gonna first reorder this so it's a bit clearer. Okay, and now maybe it's clear what I'll do next. This needs to be a 1, that needs to be a minus sign. So I pull out the 16. Okay. And usually I would suggest if you have x to a power over a constant in this term, try and simplify that. So we could say that's equal to, instead of x to the 4th over 16, we could say that's x over 2 to the power 4. All right, next step, I need that to be a minus sign. That's an easy fix. Just be careful with the negatives. The negative sign is not going to be the power 4, just this x over 2. All right. Now that I have it in this form, I can find a power series for this part easily. I just plug this negative x over 2 to the power 4. I plug that into my parentheses for my power series. Okay, and then I've got an x squared over 16 out front. And this x squared over 16, I could write that as x over 4 squared, but let's you know, we don't have to do that. We could, but let's leave it for now. Okay. Kind of come back out here to the middle. So now let's just start simplifying this power series. Let's see, I got my x squared over 16 out front. Let's see, I got -1 to the n, x to the 4n over 2 to the 4n, right? Okay, and you know, now let's yeah, actually it might help to simplify this. Okay, we got x squared over, let's see, 2 to the 4, right? I got my power series. All right, now let's bring this stuff outside. Let's bring it inside the power series. Let's see, 4n, and then I'm multiplying by x squared, so it should be x to the 4n plus 2. What about the denominator? I have 2 to the 4n plus, and then I should add another 4 to my exponent here. Okay, so this should be fine for my power series. I could simplify this further, but that should be fine. If I wanted to simplify it further, maybe I could write it as something like this. But I think this would be acceptable as well. And you know, if I'm grading, it looks like I'm probably going to be grading your finals, so this would totally be acceptable for me. Either one of these, really, as long as we have everything inside the power series. Okay, that should be fine. Oh, and you know what? Let's go ahead and find the interval of convergence for this. So let's kind of use this one here. Finding interval of convergence comes down to ratio tests. So I do my an plus 1 over an. Okay, what would that give me? Simplifying, we should end up with x to the 4th over 2 to the 4th. And we want, let's see, absolute value of that to be less than 1. In other words, we want x over 2 to the 4th less than 1. Okay, when I have, let's see, so what would I want to take the 4th root of both sides. So really, I just end up with x over 2. I want that to be less than 1. In other words, I want this. Okay, so this is the beginning of my interval. I need to test the endpoints. okay, by plugging them into this series. So if I plug, let's see, -2 in, I'm just going to end up with a constant. Okay, so these endpoints are both going to be divergent. And again, that's something you can check on your own, verify, maybe I'm wrong. So I wouldn't want to include either endpoint. So my interval of convergence should just be -2 to 2. And then my radius of convergence would also be 2.
All right, now let's kind of get into our next batch of techniques, which are going to involve integration and differentiation. So I'm going to use this when I'm given a function in 11.9 that I can't easily convert to something like 1 over 1 minus x, or 1 over 1 minus something in parentheses, right? So 1 over 1 plus x squared, that'd be an example. I couldn't easily convert this to 1 over 1 minus x using my previous technique. Okay, I can't easily do that. But let's see, how are these types of things related? Okay. Let's see, let's look at 1 over 1 plus x for a second. Okay, which I could write as 1 plus x to the -1, right? Look what happens when I take the derivative of this. Okay, I think chain rule. That would be -1, 1 plus x, -2 times the derivative of what's inside, which is 1. Okay. So that's really close to the function I was given, right? I wanted the problem I was working on just a second ago, I want to find the power series for this thing. And okay, that's if I just take the derivative of this, I can find a power series for this thing, right? Okay, they're just different by a minus sign. Okay, so that maybe gives me the idea that this function is the derivative of this. Okay. So this step was just kind of I'm just trying to show you that when we have 1 over 1 plus x and we differentiate, it's pretty much just going to become, we're just going to increase the power here, and then maybe we have a sign change along the way, okay? So that's how these powers are related to something we're more familiar with. So if I had 1 over 1 plus x cubed, maybe that's the second derivative of something that I can use, okay? Maybe that's the second derivative of 1 over 1 plus x. Okay, maybe it's not. So how can we figure it out? All right, and this is the technique I would use. When they give us 1 over 1 plus x, okay, I'm thinking this is probably the derivative of something that I can find a power series of. But what is that something? How do I find that? Well, what's the opposite of differentiation? It's integration, right? So let's say this is the derivative of something I can find a power series of. How do I figure out what this is? Well, if I integrate this side and integrate this side on the right, the integral and differentiation are going to cancel out, right? So I'll end up with integral of this is going to be the function that I want to find the power series of, all right? So that's the idea. So let's try it. 1 over 1 plus x squared. Let's try and integrate this, all right? That's the same as 1 plus x to the -2. Can I integrate this? Yeah, it's just a simple u substitution. Now, can I find a power series for this? Yeah, I can, right? I pull out the -1, and I have 1 over 1 plus x. I change that to this. Okay. I can find a power series for this. It's this. I got a -1 out front. Okay, I know I'm going really fast, but you can rewatch and slow it down. So let's summarize what we know. I started with this function. I want to find a power series for it. All right, I can't find a power series for this thing immediately, but if I integrate it, I should get a function that I can find a power series of. All right, so I integrated my function, and I get this, and I can find a power series for that, and it is equal to this. So let's just summarize what we know. Okay, if I integrate my original function, I get this power series, right? I can find this power series. But what does that mean for the power series of this? Okay, well, I want to get rid of the integral sign on the left-hand side. So what do? I differentiate. I want to differentiate both sides. Okay, so I need to differentiate my power series over here. Okay, so on the left-hand side, the integral and the differentiation cancel out. And on the right-hand side, what's going to happen? I'm just going to differentiate my power series. Pretend that integration sign's not even there. If we didn't have the integration sign on this right side, how would I differentiate this? Okay, I would treat this part like a constant. And then how do I differentiate x to the n? It just becomes n x n minus 1. Okay. And then just put the summation sign back in front. Boom. Okay. So the power series I was trying to find should be this. And sometimes you'll see the text, let's see, we could start the series at 0 or we could start it at 1 and we wouldn't have to change anything inside the series, okay? So we could start this at 1. We could start it with 0 at 0 and it wouldn't change anything. To see why that is, just try and write out this series, the terms of this series, okay? You'll see that if we start the series at 0, the series is 0. Let's see, what would be this next term? If we plugged in 1, we would get +1. And then the next one would be okay, and so on, okay. So this is the series starting at 0. And then the series starting at 1 would be 1 minus 2x plus blah, blah, blah. So these are really the same thing, right? It's just in this first one, I have a 0. Well, having a 0 out front doesn't change anything. So really, these are the same thing. All right. Interval of convergence, again, I just do ratio tests. Yeah, so just I'll kind of skip the ratio test on these and just show you guys finding the functions. How about a power series for this? Actually, you know what? In order to kind of keep working with the integral stuff, I'll use a different example. Here we go. This is a good one. What if I wanted to find a power series for x over 1 plus 4x? This will be good because we'll combine the couple techniques. I want to find the power series for x over 1 plus 4x squared. Okay, so let's see. First thing I'll do is I'll pull this x out front and then consider 1 over 1 plus 4x. Squared. Now, can I find a power series for this piece? Okay, yeah. This is going to rely on my integration differentiation tricks. What would the power series for this be? Well, let's see. Let's see, this square would screw me up. If everything on the bottom is squared, that's going to screw me up. But since I have a power here, that makes me think this is the derivative of something I can find a power series of. Okay. How do I figure out what that something is? I integrate. Okay. So what is the integral of this? Let's see, just rewriting my function here like this. Okay, u substitution. Okay. So this should be my function, right? Now, can I find a power series for this thing? Yeah, let's see. That would be negative 4x to the power n. Then I'd have negative 1/4 out front. So pulling everything inside my series, I should get this. All right, this is the power series for this piece, right? So then I have an x out front. Don't forget that x out front. So the power series for my original thing, let's see. So right now, oh, and that's, I've made a mistake here. This is actually the power series for this function here. Okay, so right now I have negative 1/4, 1 over 1 plus 4x equals this power series. All right, what about my original function? My original function was this, which is the derivative of this. Okay, and since this thing equals this power series, I can say x times 1 over 1 plus 4x squared should equal the derivative of this power series. Okay, so let's just differentiate this power series. Okay, ignore the summation sign and treat these like constants. And we'd end up with this. So this should be the power, and then let's see, I would have an x out front. I should have an x out front of all this, right? Because of this term here. So x, 1 over 1 plus 4x squared should equal this. Last step is just to bring this x inside the power series. Okay, when I bring the x inside, I got n minus 1 plus 1, so just x to the n. And that should be our final answer. So this gets complicated, obviously, when we start doing integration and differentiation, but we just got to get through it. Luckily, 11.9 is not too, like, we can do this using, well, sometimes we can do this using a different method from 11.10 where we just find the derivatives of our function, but we should be able to do this as well. Okay, so now let's just see another example. What if the function they give me is ln 1 plus x to the fourth? Okay, so I can't directly make this into a function like 1 over 1 minus something in parentheses because ln is not related to this at all, seemingly, right? Okay, but what if I just had, so we can discover the connection, let's look at 1 over 1 plus x. That's the integral of 1 over 1 plus x, right? I can find a power series for this, so I should just be able to take this power series and integrate it and get a power series for this thing, all right? So what if they give me a more complicated function like ln of 1 plus x to the fourth? This should be the integral of something. And that's something I should be able to find a power series for. How do I figure out what this is? Okay, differentiate both sides. If I differentiate both sides, okay, these two will cancel and I'll have the derivative of this thing, okay, is my function. Okay, and we'll see how that works. Okay. So let's differentiate both sides. Okay. And really, since there's nothing on the right side, let's just differentiate the left side. If I differentiate this thing, I end up with 1 over 1 plus x to the fourth times 4x cubed, right? Chain rule. Okay. I can find a power series for this part. Okay. So let's find a power series for 4x cubed 1 over 1 plus x to the fourth. Power series for this thing is okay, and then I got a 4x cubed up front. I bring the 4x cubed inside. So this is the power series for our function on the right side. Okay. So let's see, I know d dx of ln 1 plus 4x squared equals this power series. Okay, now to get the power series for this, I need to integrate both sides. Okay, what's the integral of this power series? Okay, just treat this like a constant, integrate this piece. We would have this. And then plus a constant c, right? Plus a constant of integration. And I need to figure out what that plus c is. Before we do that, let's just simplify everything a bit. Four n plus 4, I can simplify that as 4 times n plus 1. And then these 4s would cancel. It's not super important, but we should try and simplify as much as possible. Okay, how do we figure out what this plus c is? I'm going to plug something into both sides of my equation for x. Okay, so a good choice is usually 0. If I plug 0 into the left side, I get ln of 1, right? Which is 0. Okay, what happens if I plug in 0 for x on the right side? Let's see, all these x's will be 0, my entire series will be 0, and I'll just be left with c. Okay, so in this case, when I plug 0 into both, in this case, c just ends up being 0. That's not always going to be the case. For most of our problems, maybe it will be the case, but not always. So this is maybe something you don't see very often because it's, we usually are given nicer problems where c is always going to be 0, but it's not always going to be the case. Okay, so I find out, to conclude, I discover that my power series for ln of 1 plus 4x squared is this. Let's see one more of these examples. How about finding the power series for ln of 5 minus x? So I see ln and I'm thinking, okay, this is probably the integral of something I can find a power series of. So to figure out what that something is, I differentiate both sides. Okay, so I differentiate the left side and I get this thing. Can I find a power series for that? Yeah. Okay, so let's see, I can find a power series for this piece. And I get this thing. All right. Next, all right, so this is the power series for, okay, this guy. So let's summarize what we know. D dx of ln of 5 minus x equals this guy. All right, so how do I find the power series for this? I want to get rid of the differentiation symbol, so I just integrate both sides. On the left, I get ln of 5 minus x. On the right, I get integral of my power series plus c. All right. So let's see, what's the integral of my power series? Should be this. Now, this will be a good example because c is not going to be 0 in this case. How do we figure out what c is? Again, let's plug a value of x into both sides. Plug in 0. On the left side, I get ln of 5. On the right side, this whole thing is 0 plus c. So I see that c is ln of 5. Okay, so the powers, that means the power series for my function is ln of 5 plus, okay, so this is my c, plus the rest, plus this thing. And then there's really no better way to write this. It might seem weird to have just a constant out front. That's fine to do. Okay, so our final answer should be this thing. I just looked up the answer in the back of the book to make sure I was right, and I am, but the book has written it in a different format. The book has written the answer as ln of 5 minus this. And the series is actually starting at 1. This is actually the same as this. Okay. So either one of these, if you were writing a test, either one of these would be acceptable. Let me make sure that's actually correct. Let's see, is that correct? Yeah, it is. Either one of these would be acceptable. All right, so why is that the case? When we change the starting index, in this case, it's going to change the form of our series, but they are equivalent. They're the same thing. And you could write out a couple terms of each of these series to see that's the case. In general, if we ever want to change where our series starts, we can follow this rule. If we want to add one here, we subtract one here. If we want to subtract one here, we add one here. So for example, 1 over n plus 1 starting at 0. Okay, if I want to start my series at 1 instead, so I'd add 1 here, I'd subtract 1 on the inside. Okay, same thing. And to see that, again, you could write out several terms of each of these and see that they're the same. If I wanted to, let's see, if I had my series starting at 1, I could subtract 1. Let's see. If I wanted to start my series at 0, okay, so I'm subtracting 1 here, I would add 1 on the inside. All right. So I think that's, with that last note, that'll be enough problems for section 11.9, and I will move on to section 11.10.